In this video, we're going to walk through a basic example for conducting an F-test for equal population variances. So we're going to try to compare our S1 squared and our S2 squared values. And to do that, we're going to use our hypothesis test, where our null hypothesis is sigma 1 squared is equal to sigma 2 squared. And our alternative hypothesis is sigma 1 squared does not equal sigma 2 squared. And this is going to be our two-tailed test. And we're going to set alpha equal to 0.1. So that will mean our alpha over 2, or our f of alpha over 2 will be f of 0.1 divided by 2, so 0.05, comma, we have v1, and we have our v2. And we'll figure out what those are in a second. But let's figure out what our f value actually is first. So we're going to say f is equal to, we have s1 squared over s2 squared is equal to 8 over 10. But in this instance, we run into a problem. Since 8 is smaller than 10, we actually need to flip our f statistic upside down. So we're going to change that. We're going to get rid of that one, and we're going to say our new f statistic is actually equal to our s2 squared over our s1 squared, which is now going to be equal to 10 over 8, which is equal to 1.25. So that will be our new f test statistic. And remember, we always have to make the numerator, the top value, larger than the denominator, so the bottom value. So this value will always be greater than or equal to 1. So now we're going to actually use our f stat. So we need to look at v1 and v2. So v1 is the degrees of freedom for our numerator, so our top, which if we look at our value over here is our n2. Since we again moved s2 to the top of our fraction, we need to look at n2 for our degrees of freedom. So our f value is going to be f with alpha equal to 0.05, or alpha over 2 equal to 0.05, with 13 minus 1, or 12 for v1. So v1 is equal to 12. v2 is equal to 10 minus 1, or 9. We get an f value of 3.07, so we get equals 3.07. And now to actually finish off our hypothesis test, we're testing to see if f of 1.25 is f equals 1.25 greater than our 3.07, which is equal to our f sub alpha over 2. And since it is not equal, or not greater than, we fail to reject. So we fail to reject h naught. So this will be probably one of our easiest hypothesis tests. We just divide one value by another that we basically already calculated. The only issue is looking it up in the F table and making sure that we're dividing the right number by the right number. So remember, our F stat is always dividing the larger value by the smaller value, and then based off of those values, we can look it up our F value for f of alpha or alpha over 2 based off the number of degrees of freedom from the numerator and the denominator.